Good morning and welcome, everyone. I'm seeing some people already saying hi in the chat. Hi, Mimi. Hi, Dina. Hi, Gianna. Welcome to Girls and STEAM Learning to Code with CodeJoy. I'm going to take my glasses off here so you can see my eyes a little bit better. But good morning and welcome. My name is Madeline and I will be your Science World host for today. Firstly, I would like to start by gratefully acknowledging that Science World is located on the traditional and unceded territories of the Musqueam, Squamish, and Tsleil-Waututh nations. And we are very grateful to be able to work and play on these lands. Before we dive in today, I would just like to remind everyone that this is a safe space. So please keep your comments in the chat respectful and on topic. But we love to hear from you in the chat. So why don't we test that out a little bit right now? Let me know where you're joining from today. I am currently in the Omni studio of Science World. So when you look at Science World, there's that big globe at the top, and I am in between the walls of that globe right now. You can see it a little bit in the background there. As we move through today, we will be starting on YouTube just to do this little bit of an introduction, and then we will be moving over to CodeJoy's website, which will pop a link in the chat, and there's also in the description below. And Kelsey, who is our CodeJoy host today, will also talk you through how to get onto that platform. So I'm seeing some highs here. Hi, Becca. Where is everybody joining from today? Let me know where you are in this wonderful world. Like I said, I am here at Science World in Vancouver. Checking my notes here is right before we start the session. Hello, I'm seeing more highs. All right. I would also like to thank our sponsors. Without them, we would not be able to do amazing Girls in STEAM events like this. So we have SAP and Actius, who have sponsored our Girls in STEAM online events today. Oh, great. Oh, Baton Rouge, Richmond, Vancouver. Awesome. Welcome, everyone. All right, so I'm going to hand it over to Kelsey now, who, as I said, is our CodeJoy host for today. And you'll also get to meet some fun friends of Kelsey's. So welcome, Kelsey and Matt.
Good morning, everyone. Hello. We are so excited to be here. My name is Kelsey, and do you want to introduce yourself too?
Sure. My name is Matt the Robot. How you doing today?
That's right. Matt the Robot is the director of our show, and he comes to us live from his studio, which is located underneath my kitchen sink. So if you're wondering what that U-bend situation is, it's a kitchen sink. You've seen one before. Looks like this probably, right? But we are going to be covering some coding and robotics today. And rather than just showing you cool and cute robots, we want you to actually code and control them. We want you to help us code today to play a very fun game. Hey, Matt the Robot, will you tell them what we're playing today?
Sure thing. We're going to be playing some robot mini golf today. So hopefully you all are mini golf fans. And if you're not a mini golf fan, hey, maybe you're a robot mini golf fan.
We hope so. We're going to teach you how to code, and then your code is actually going to control our robots. So whether you're joining from Vancouver or Baton Rouge or Oakville or, you know, any of the other places you guys said, from Delta, from North Vancouver, we're in Pittsburgh, Pennsylvania, and you are going to control our robots live, which will be really fun. Elby? So distracted this morning, but it's time to get started with Science World. Well, hello everyone and welcome. I am so glad you're here. My name is Kelsey and I'm going to be your guest teacher today while we learn about coding and robotics. We're going to teach you guys how to code, and your code is going to control our actual robots while we play some robot mini golf. Now, there are a couple of robots you should know this morning. My friend Elby, he lives back there behind my wall, and he is going to be playing some robot mini golf today with our help. But there's another robot you should know. He is the director of our show, and he's coming to us live from underneath the kitchen sink. Hey, Matt the robot. How's it going?
Hey, Kelsey. It's going great. How are you doing?
I'm doing great. Do you want to tell everybody what your job is down there under the sink?
Sure thing. So it is my job to monitor the chat. So anything that you type in the chat, I can read. So if you have any questions or comments at any point during today's show, please type those in the chat. Speaking of questions, I've got a question for everybody here. I am wondering, what is your favorite sport? What is your favorite sport? Go ahead and type that in the chat and I will bring it into the show.
That's right. So on CodeJoy Live, we can't see you and we can't hear you, but we can read your chats and your code, which we'll teach you how to do in just a little bit. But for now, tell us in the chat, what is your favorite sport to play, to watch, etc.? What are they saying, Matt?
Well, the answers are coming in fast. Let's see. Grace likes swimming. Nikita likes soccer. Nina also likes soccer. Elia also likes soccer. Toby is a dancer.
Ooh, very nice.
Let's see. Bo says, my favorite sport is probably gauge ball and swimming.
Cool.
Dodgeball, I'm guessing is what that was.
Yeah.
Dodgeball and swimming. Thanks. Caitlin likes skating. Casey, also a skating fan. Caitlin and Casey, you guys should get together and skate sometime. Doris likes basketball. And Kara says, my favorite sport is swimming or dance. There's a whole bunch of other answers in here, too. Can't get to them all, unfortunately, but it looks like we got a really sporty group today.
I love that. I love all the folks who said dodgeball. I haven't played dodgeball in forever. We should do a robot dodgeball show. That would be really fun.
Really good idea.
Today, we're doing some robot mini golf, and Elby's going to be the one to help us back there. So let's go see if he's ready to play some mini golf. Hey, Elby, you ready to golf? Elby. Hey, what has you so distracted, bud? Oh, yes, that is a very nice kazoo, but it looks like in order to win it, you're actually going to have to score a hole-in-one. So, are you ready to play? Excellent. All right, everyone, let's head over to our first mini golf hole. Now, when we arrive at that first hole, we're going to investigate the obstacle that we find there, and then you guys are going to help Elby score a hole-in-one.
Oh, no. The unfair way? I've heard of this mini golf course. I've got a very bad feeling about this.
Oh, Matt, you worry too much. I feel great about this. Let's take a look. Okay, I don't feel so good anymore.
Yeah, this place is a total scam. I don't think it's going to be possible to get a hole-in-one on any of these obstacles.
No way. Did you guys see how fast that thing was moving? This game looks totally unplayable. Elby, are you sure you want to play mini golf here? Okay, well, take a look, everybody. Here's how we're going to play some mini golf. Do you see that little green hill in the middle of the screen? Well, that is our putter. And later on today, we're going to give a few of you individuals a chance to control that putter. So that's how you aim the ball and how you hit it. Looks good, Elby. Go ahead and putt. Fingers crossed. Oh, man. Tough break.
Yeah, this is a really old mini golf course. I think these obstacles are just running old code.
Ah, well, hey, if they're running code, code controls robots. So if we want to change the robot, we just need to change the code. Let me show you how to do that, everybody. So you're with us on our site here, CodeJoy Live, and you're probably on the tab at the top that says Home. We want you to go to the tab that says Obstacle 1. You'll see your video and chat along the top, and then if you scroll down a little bit, you'll see this. this is the code that is controlling that first obstacle. So let's take a moment to understand it. It says rotation servo 1, 100. What's that all about? Well, that is about a rotation servo. So a rotation servo is a motor, and it's a particular kind of motor that rotates. This little bit on the end spins around and around and around. And whatever you put on the end of it, like say the blades of a windmill, that's what is also going to spin. And you can control how fast or slow that spins with a percentage. So as you can see, our windmill is currently set at 100% speed, which is the most it can possibly be, right? And that's too fast. So what we want you to do is type a number in here that's less than 100 that you think might make this game a little bit more playable, a little bit more fair. And then when you've got a percentage in there, click send code. That'll send your code to us so that we can try it out on our robots. So I'll come down to you, Matt. Let me know when they've sent in some code and when you've got one for us to take a look at.
Sure, those codes are coming in fast. Let me go ahead and take a look here, see what we've got. Check it out. We've got this great code here from Eliana.
I think it's Elena.
Elena, thank you so much.
Absolutely. Elena has suggested 45% speed. I love that, Elena. Let's load your code on our robot. Okay, there it is. It's going 100% speed. Let's stop the old code and start the new code, and there's 45% speed. Do you think it's going slower, Elby? Yeah, I think so too. It's definitely going slower. What do you guys think? Is that slow enough? Should we try to slow it down some more? Maybe Matt can find some different codes. What do they think, Matt?
Yeah, so we're getting some, Grace believes that we should have it slowing down a little bit more. Hunter also thinks it should slow down a bit more. Elia also believes a little bit slower. So yeah, let's go ahead and look for some a few other codes here.
All right, so we want something slower than, what did we have this at? 45.
45.
So we're looking for something slower than 45. Did you find anything, Matt, that we could try out?
I did. We've got a code here from Pippa that I think is going to be great.
All right, Pippa, what you got? Nice. Pippa says, you know what? 45 was too fast. Let's slow it way down. Let's set it to 3. 3% speed. Let's try this out, Pippa. Okay, I'm going to stop the old code and start the new code, and don't adjust your televisions here, folks. That is 3%. What happened? Tell me your observations in the chat. What did 3% speed actually do? Tell us in the chat what you see, everybody. This 3% speed. What are they saying, Matt?
Grace says it stopped. Audrey says the same thing. So does Bo. Bo says totally stopped. Sophie is saying nothing.
Yes, absolutely. So what we just learned, and Pippa, I am so glad that you brought this up, because 3%, I was saying that that percentage was speed. Technically, it's not actually setting the speed of it, it's setting the power. How much power are we sending to this motor here? And as it turns out, 3% power is not enough to get those blades spinning, especially when you consider some other like physics things like friction. Things rubbing against each other can make it harder to make them move, or the weight of the blades. So Pippa, you just taught us a huge difference between coding and robotics, which is code controls robots, but sometimes those robots don't behave exactly like you think they would. That was a great lesson, Pippa. All right, so we want to get them spinning again, at least a little bit. Matt, can you find a code that's faster than 3?
Yeah, we've got this great code here from Talia.
All right, Talia, what you got? Talia is suggesting 15% speed. Okay, so that's slower than 45, but faster than 3. Let's see if that gets our windmill moving. Okay, so we're gonna load that on our robot. We'll stop the old code and start Talia's code. There's 15%. What do you think, folks? Too fast, too slow, just right? Tell us in the chat. Should we keep looking?
Hunter really wanted to see what 10 looks like, but Elena says seems fine. Elia says perfect, and Caitlin says it's good.
This is good. What do you think, Elby? You're our robot on the ground. What do you think? Yep, 15. Okay, excellent. We'll stick with 15%. That is what will power our windmill today. So that's great. I think we're ready to golf on it. So, Elby, you ready to get to golfing? No. Okay. Why not? Oh, actually, that is a great idea. Elby was saying that instead of him golfing, you guys should golf. So let me show you how to do that. If you're on CodeJoy Live, which you are, head over to the tab at the top that says Let's Putt. Now, once you get to that tab, find the little yellow button next to your chat that says Volunteer. Click that yellow Volunteer button, and that will let us know that you're on the Let's Putt tab and that you want to be the one person to control our little golf putters, because we're going to give one of you live control. So head to the Let's Putt tab, click the yellow Volunteer button, and I'll come down to you, Matt. Who is our first golfer going to be?
Let's go ahead and give control to Michaela and Connor.
All right, Michaela and Connor, you guys have live control of our putter. Let me show you how to golf really quick, because even if you're not Michaela and Connor, pay attention though, because you might be our next golfer. All right, so golfing is a simple 3-step process. Step 1, you're going to use your mouse or your finger if you've got a touch screen and move this little slider bar around. Step 2 is you'll click the button that says Move Putter. That's what'll actually move the little putter to point different directions. So you'll do those 2 steps over and over again. So move the slider bar, click Move Putter, move the slider bar, click Move Putter. You can also click these arrows if you want to make really small changes, but to see it move, click Move Putter. And then once you've got it all lined up, click Putt, and that will actually hit the ball. So Michaela and Connor, it's your job to try and get a hole-in-one. Everybody else, it's our job to cheer them on. So what do you think? Do Michaela and Connor have what it takes to get a hole-in-one? What do you think, Elby? Elby believes in you, Michaela and Connor. How about everybody else?
Elia says yes. Kara says, go Michaela and Connor. And Rui says, you got this.
And Michaela and Connor, if you guys are having any issues, let us know. But just move that slider bar and then click Move Putter. Yes, you're doing it. That's you.
Toby says go. Sophie says yes. And Caitlin says go, Michaela and Connor.
Well, I'll put on my golf announcer voice here. They're lining up their shot. They're finding the full range of motion of the putter. It's very important. Very, very important. Oh.
TT is chiming in with, you can do anything. I believe TT is correct.
I think so too.
Elena is sending you a bouquet of exclamation points.
That's my favorite kind of bouquet to get, actually, Elena.
Oh, Michaela's saying it's not active. You are actually moving it, Michaela.
Yes, can you see it? Oh, there's 2 Michaelas. There's a Michaela, which is A-E-L-A. We gave control to the Michaela that's M-A-K-A-Y-L-A, so someone that's signed in as Michaela and Connor. So that might be why that Michaela is confused.
Thank you for catching that.
Yep.
Yep. All right, it's getting lined up.
Ooh, we're getting close.
Dialing in.
Cross your fingers, everybody. Oh, yeah! Fantastic! Round of applause. Oh my gosh, did you guys see that when it went in? Some little flags popped out. We heard a little noise. This was amazing. I bet the chat is just lighting up with praise for Michaela and Connor.
They're going nuts. Bo says, wow. Emily says applause. Grace says, great job. Willa says, yay, 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 yay. Rui says, you rock. And Rui's right.
You do rock. That was amazing. Listen, kids all over Canada and the US are lighting up with praise for you, Michaela and Connor, because they knew you could do it, and you did. But you do know who's the most excited about all this? That's right, Elby. Let's go get your kazoo, bud. All right. Score a hole-in-one, win a prize. Wait, hold on. Times 2? What? Oh, man. I thought we only had to get 1 hole-in-one to win a prize. Turns out we got to get 2, but you know what? This is okay, actually. Elby, this is fine. We're at a mini golf course. Why don't we just go to the second hole and get a hole-in-one there? All right, I got a good feeling about this one, folks. I think this is going to be much easier. Let's take a look. You're right, Elby. This one does not look easier. This one, in fact, has teeth, which is fine. totally fine because it's just a robot. And remember, if we want to change the robot, we just change the code. So let me teach you how to code this robot. You're probably still on the tab at the top that says Let's Put. Let's head over to Obstacle 2, the tab at the top that says Obstacle 2. You'll see your video and chat along the top and scroll down and you'll see this code. This is the code that's controlling the second obstacle, and you might notice it looks a little different from our Obstacle 1 code. That's because in Obstacle 2, we're controlling a position servo, which works a little differently. Let me show you what I mean. So a position servo looks very similar to a rotation servo. However, it works a little differently. So I'm going to move this top around, and you probably will see that as I push it with my finger, it doesn't go all the way around. It doesn't rotate around and around and around like a rotation servo. Instead, a position servo only has about a half turn worth of movement. Why is that? Well, it's because you don't control a position servo with percentages, you control it with angles. So when you set your position servo to different angles, like 10 degrees or 45 degrees or 90 degrees, it'll go to that angle and it'll stay there for however long you tell it to. So if I show you with our model crocodile here, 0 degrees is going to be the mouth all the way closed, and for us, 90 degrees is as far open as we're going to let that get, because if you open it all the way, the ball just rolls right through. So we're going to stop it at 90. So there's our range of motion. So you could set it to any angle between 0 and 90. Let's see what they have it set to. Okay, so it's going from 0 degrees, which is closed, to just 15 degrees, which is not very open. Let's see what that looks like on the actual robot. There's 0, and there's 15. So that's the first thing that we want you to change in this code is change up your angles. Put 2 different angles in there, anything up to 90, but just make sure at least one of them is bigger than 15, because 15 is not even wide enough to golf against. So that's the first thing we want you to change. But there's another thing that's making this code challenging. So let's take a look at what these blue blocks do. They say pause MS in parentheses, and then they have some numbers after them. Well, a pause block tells a robot how long to do something for. So how long should it be at 0 degrees? How long should it stay at 15 degrees? And pause blocks are measured in milliseconds. So there are 1,000 milliseconds in 1 second. So you can see that it's going to go closed to 0 degrees for 2,000 milliseconds, or 2 seconds. And then it's going to open to 15 degrees, but only for 200 milliseconds, which is 0.2 seconds. And we can actually even count this out. Ready? 1, 2, 0.2, 1, 2, 0.2, 1, 2, 0.2. So that's the other thing we want you to change. The biggest number you could put in here for these pause blocks is 5,000, or 5 seconds. So change up your angles to make it wide enough to golf against, and change up your pause block so that it's open for long enough for us to actually get a hole in one. And then when you've got some code you're proud of, just click Send Code. That will send your code to us so that we can put it on our robot. I'll come down to you, Matt. Let me know when you've got a code for us to take a look at.
Oh man, we've got so many to choose from. It's going to take a little second here. Hey. Check this out. We've got this great code here from Lakeitha.
Lakeitha, let's see what you got. Lakeitha is going to have it go to 50 degrees and then 80 degrees with a full 5-second pause in between each. Lakeitha, let's see what this looks like. Okay, gonna head over here. We're going to stop the old code and start Lakeitha's code. So it looks like there's 50 degrees for 5 whole seconds. And then it's going to move to 80 degrees for 5 whole seconds. Let's see if we can count it out. Ready? 50, 2, 3, 4, 5, 80, 2, 3, 4, 5. And then it loops back up to the beginning and starts again because it's in a forever loop. Guys, Lakeitha's code is looking awesome. Question for you though. Do you think this is playable? Could we even score a hole-in-one on Lakeitha's code? Because the last code, we couldn't. It wasn't playable. Is this one playable? What do you think?
Well, Emily thinks it is. Emily's concerned that it might be a little too easy, as is Elena. Grace says, I think we can. Toby and Talia both say yes.
Elby says, it's not too easy. I think Elby's got ulterior motives, you guys. So, this is great, though. Lakeithia, that was an amazing code. I just want to take a look at a couple more, though. Matt, let me come down to you. Whose code should we take a look at next?
We've got this great code here from Kara.
Kara, what is Kara saying we should do? Let me zoom in a little bit. Kara's going to have it close all the way, 0 degrees, and then it's going to open almost all the way to 85 degrees. It's going to stay closed for 500 milliseconds, which is half a second, and stay open for 5 whole seconds. Kara, let's see what this looks like in action. Okay, I'm going to stop the old code, and it'll take a second for it to finish running through. I think it's going to stay there for a minute. Okay, now I'm going to send the new code and start it. Okay, there we go. 2, 3, 4, 5. Look at that. What do you think of Kara's code, everybody? Perfect, too hard, too easy, playable? What do you think, everybody? Let us know in the chat.
Toby says good. Bo says cool. Rui believes that this might be a touch too easy, as does Abby. Audrey's walking the line saying, I don't quite know, but Abby says nice.
I think it is very nice, Kara. That is some great coding. But I just love taking a look at kids' code. Kara, that is totally playable. We could totally use that. But let's see if we can maybe take a look at maybe one more. I'll come down to you, Matt. Maybe you can give us one more code to take a look at.
Sure. Oh boy, whole bunch to look at here.
That's right.
Hey, we've got this really cool one here from Doris. Let's try this out.
Doris, what you got? Doris is gonna have it closed to 0 degrees, and then they're gonna have it open to 45 degrees, and each of those is just gonna last half a second. Let's see what this looks like, Doris. Okay, we're gonna stop the old code and start the new code. There you go. Doris has got some code here. Is it too hard? Is it too easy? Is it just right? Have we found our Goldilocks code? What do you guys think? I think this is some great code, Doris. What are they saying, Matt?
Hannah thinks this might be a little too hard, but Talia says this is amazing, and Ishveen says good.
Yeah.
Let's see. Prisha says this might be a touch too hard. Sophie says good. You know, we're getting all sorts of opinions here. What does Elby think?
Elby, you're the one that's closest to it. Do you think the ball would fit in, and do you think we could actually golf against it? What do you think? Yep. All right. Elby's our robot on the ground. He's been playing this game for the same amount of time we have, but here we go. We are gonna stick with Doris's code on our crocodile here. It's looking great. Now, we just need a golfer. So, if you want to be our second golfer today, head over to the Let's Putt tab and click that yellow volunteer button, all right? Head over to the Let's Putt tab, click that yellow volunteer button, and then we'll know you're in the right place and you really wanna golf. So Matt, I will come down to you. Let me know who our second golfer will be today.
Oh man, looks like we got a lot of folks that would like to golf, but Nina, why don't you go ahead and take control?
All right, Nina. Nina, we just gave you live control of our putter. So a quick review on how to putt, Nina. Step 1, move the slider bar either with your mouse or with your finger if you've got a touch screen. Step 2, click Move Putter. That's what'll actually move the putter, and you'll do those over and over again. So slide this, click Move Putter. You might use the arrow keys if you want to make small adjustments, but you always have to click Move Putter. And then, Nina, when you've got it lined up, click Putt. That is what will actually hit the ball. So Nina, it's your job to play against Doris's code and try to get that ball in the mouth. But everybody else, it's our job to cheer Nina on. So can she do it?
Hannah says, I think we can do it. Becca's worried it might be a touch hard, but Rui believes in you.
Oh, look at that. Nina's lining it up very carefully. Oh, man.
Caitlin says, go, Nina, go. Hannah says, go, with a whole bunch of exclamation points afterwards.
This feels like the moment before jumping into a jump rope. The tension is high, but Nina, I can tell you've got a calm, cool, collected manner. Oh my gosh, look at that! Amazing! That was awesome! Did you guys see that? It went right in the mouth and then the little tail wagged in the back. Nina, that was amazing. What are they saying in the chat, Matt?
Hannah says, OMG, yes. Caitlin says, yay. Audrey says, yay, 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 yay. Michaela and Connor, who know how difficult it is to do the golfing, say good job.
Excellent, excellent job, Nina. Man, your friends all over the world are so excited for you. I'm excited for you. But do you know who's the most excited for you? That's right, Elby. Let's go get your kazoo, buddy. I forgot. Elby can't catch. That's all right. You know, I'll let me help him out. Hold on. Let me just reach in there and see if I can find that kazoo. It's kind of hard to reach. Is it over here? Okay, great, great. Got it. Okay. Hey, Elby, do you want to play us a song on your new kazoo? Yes, okay, excellent. Play us a song. Okay, wow, that was quite the song there, buddy. That was a little moist, actually. I'm just gonna set that right there, and maybe you guys can review Elby's song. Best song ever, worst song ever, more like Tina Turner, more like Taylor Swift. Who would you say? What's his style? I don't know. I'm struggling here, Matt. What should we say?
Bo was wondering if that was done with auto-tune. Audrey says it's really nice.
The first time anyone's ever said that, Bo. That's really funny. That's great.
It gets a solid 6 out of 10. Let's see. Christine says nice. Hannah says so cute. Ishveen says Justin Bieber.
Oh, I think that is a really accurate comparison. Just kidding. I don't want to disrespect Canadian culture. I know that's very important. Listen, the thing that I love about you guys is you're funny and you're kind. I really like that about you. You guys are awesome. Now, there's something that we like to do at the end of all of our classes. That's the end of the coding portion of our class. But there's something that we really like to do at the end of all of our classes, which is to go to our behind the scenes camera and just kind of open it up for questions from you guys. So we're going to go there now. There's our behind the scenes camera. And what do you guys want to take a closer look at? So now you can see our entire studio. We can go take a look at any of our robots. We can go inside the windmill or behind the crocodile or wherever you want to go. What do you want to see? Let me check in on the chat. Rui says, this is great with a million question marks. Sounds like a question, but it's actually a compliment. I liked it. Thank you. Kara says, I have a question. Is that robot actually coded? That would be super cool. Yes, all of our robots are coded. Which one are you specifically talking about, Kara? All of our robots are controlled with coding. Maybe we can take a quick tour here. So here's where I stand. If we look down below, that's where Matt the robot is. So we can definitely take a closer look at him. Abby was wondering, how does Elby work? Excellent. Well, let me show you where Elby is first, but then we'll take a look at how he works. So here's our set, right? This is kind of like a TV studio. This is our set. This is the edge of the set. It ends. But there really is a hole in the wall. Let me show you what I mean. Real hole, real wall. But when you look down there, there's no robots. There's no mini golf down there. That's where we kind of said everything was. But it's actually not down there. That entire robot world is actually right next to me here. On this 8-foot wide table. That's where our little robot world is. And we kind of make it look like it's behind the wall, but actually it's next to the wall. But it's all real, it's all live, and it's all coded. So in answer to Kara, and then my friend who wanted to, I think it was Abby, wanted to know how Elby works. Well, we were controlling Elby with an iPad today. So let me show you. We've written some code for him, so I'm going to put this here so you can kind of see the code and see Elby. So for example, we have some code that makes him look at the camera. We have some code that makes him say yes. And if we take a look at that, for example, that yes code there, you'll notice it's controlling position servos, position servo 1 and position servo 2, and it's just going to different angles here with wait blocks, which are just like pause blocks. So when I activate that code, Elby nods his head up and down 3 times, just like that. And we have a few different codes written like that, but we are actually coding and controlling Elby live. We're coding and controlling Matt the Robot live, although he's using a computer, so we have a bunch of different systems all kind of working at the same time. But everything you guys did today, learning how position servos, rotation servos, all that stuff works, that is just like the code that we use to control our robots live during the session. So thank you, Bo. Bo says the robots are very cute. And Elena says, what did you use to code? Well, we used a bunch of different ones, and I'll go to Hunter 3. Hunter 3 really wants to see the owl. So we use a bunch of different coding languages. That one that I was using on the iPad is called Bird Blocks, so we use that one. The owl back here, this one was coded using Makecode as our programming language. So in fact, why don't we open up the owl and see inside? Ready? He's built just for this purpose. You just tape the head closed so you can see inside. Okay, so when I open it up, see all the wires and stuff, but it's got 2 LEDs for the eyes here, which kind of blink occasionally to simulate, well, blinking. And then if I lift his head up a little bit, there's a position servo, just like the one you used in the crocodile, in the neck there. And all of that is plugged in. The one thing we didn't show during the class is that all those things are plugged in to a microcontroller. So we use microbits, that's this part here, and then we plug them into a hummingbird. That's our favorite, one of our favorite things to use to make robots. We plug in the lights, we plug in the motors, and then we code it on our computer just like you guys did. So the coding language that you were using today, technically it's one that we created for our website so that people could remotely control our robots, but we created it to look and function much like Makecode. So if you liked the coding, the block-based coding we did today, check out Makecode or Scratch or Snap or Blockly. Tons of great block-based coding languages out there. Okay. Let me see. TT with Adriana really wanted to see the hand. Come here. And Willa really wanted to see that too. Let me show you the hand. The hand's pretty cool. Okay. So it's not the Infinity Gauntlet, although it's got similar colors, but that's it. But it's got these motors, and again, those are position servo motors. I'm going to grab one and show you. See? Position servo motors, just like the one you guys saw today. And as they turn, we've got a popsicle stick glued onto it. So the popsicle stick tugs on a string, which goes up through some straws, and it's connected to the top of the finger, so as it pulls the string, it bends the joints there. That's called a winch. A cable mechanism. Brain. But all of those motors, same thing. They are plugged into a hummingbird and a microbit down there. So there are all kinds of different microcontrollers. We just have ones that we like in our studio, but maybe you've used some microcontrollers like an Arduino or Raspberry Pi or a Chibi Chip or a Makey Makey. Maybe you've used some things like that. There are tons of cool things. Willis said, yeah, the hand. Can we see all the robots? You can see everything the light touches. There are some robots that are put away right now, but all that the light touches is yours to see. Grace says, I've made one of those hands before, and it looks just like that. Yeah, that's like kind of why we did that, Grace, because we know that a lot of kids make projects like that, and it would be so easy to add some motors to the hand that you made, and then like automate it. Wouldn't that be cool? I think it'd be cool. What else? Parisa says, that's awesome. And Talia really wanted to see the windmill. So, let's take a look, Talia. Should we put it up here on the table, or you want
Sure.
me to hold the camera for a second?
No, you can put it up on the table if you should move that off.
Yeah. Don't get tangled. Don't bump things. Okay. Everything's fine. Everything's going well. Okay, great. Put that there. I'm gonna scooch him off here. Okay. Here's the windmill. So I know it looked like we traveled to go from the first hole to the second hole, but maybe some of you guessed this. We didn't travel. That was movie magic. We just scooched Elby to the other side and switched out the obstacle. So here's the windmill. Now the windmill's got kind of a cool feature. So you guys were controlling the blades here. But did you notice when we got a hole in one? I'm gonna try to get a hole in one there.
Give it a try.
Yeah, when we got a hole in one, there are these flags that popped out. And that's because we built a sensor trigger into our windmill. So there is, I believe over on this side, there's an LED, the green LED here. And over on this side, there's a light sensor. So there's a light shining directly at a light sensor. So when you block the light with something like, say, a golf ball, which is harder than it looks to do, there we go. It triggers these motors on the back here to just rotate slightly and pop out. I could also do it with my hand. That works too. Whoops. And they pop off, really? See that? Okay. Just like that.
Other way.
Thank you. There we go. Yeah. So we're always just using really simple materials here at CodeJoy to make our robots, like popsicle sticks, cardboard, foam, like you might have in like a makerspace or classroom. We like to let you know that anything can be a robot. You just add motors, lights, and maybe some sensors. How do you do other shows or teach classes, says Michaela. Well, Michaela, I'll share our website with you in just a moment here. But we do tons of classes online with folks like Science World. We are so grateful to Science World for having us on today to do this session with everybody. We've had a ton of fun with you guys. But we also do classes like this for other folks as well, and even for schools. So we could come do it for like your whole school. Everybody could log on from different classrooms, which is pretty cool. But we do it through our platform like this. Yeah. Bo says he loves the croc, or they love the croc. I do too. It's one of our favorite robots. Some people were wondering how Matt the robot works. Rui was particularly interested in that. So let me come over. I'm going to hold the camera so that Matt can show you how Matt the robot works.
All right.
All right, guys. All right, we'll let Matt take a seat because he's got a whole thing, a rig to get into. Okay, here we go.
All right.
So how does Matt the robot work, Matt the man?
Well, I've got this series of buttons here that we've set up, and these buttons are connected to this computer up here. So if you look up and to the left, you'll see this code. Now this code is what is actually controlling Matt the robot. And Matt the robot, I can kind of see him right there in between all of the cables. As I hit these different buttons, it sends the robot head to different positions. And so I could make it look towards the camera, and then by hitting this button, you'll probably see in the background that Matt the robot blinks. So Matt the robot is definitely a robot in that it senses and thinks and acts. But there is a person behind this, not just doing the controlling, but obviously doing the, reading the chats and mispronouncing names and doing all the things I do so well here.
And they were particularly interested, how does he talk, which is just a microphone.
Right. Yeah, we just got a microphone here, and I got a little button that I hit every time I want that microphone to work, and when I release the button, you could probably hear me still through Kelsey's microphone, but yeah. So that way I'm able to switch cameras and do all the things that we need to do technically here. And so I'm doing all of that in the background, and then while Kelsey's teaching up front. So all of this is done really with just the two of us.
Yeah. This is a whole like TV studio with two people, but that's what is controlling Matt the robot here. Would you show us Matt the robot working a little bit again now that we know it's buttons and code?
Yeah.
It's pretty cool.
Well, buttons and code and position servers.
Yeah.
We're controlling in the crocodile.
Okay.
There's actually 3 in my head.
I have an extra credit question for you, because I can tell you guys are the kind of kids who like extra credit. Which is, What do you think Matt the Robot's eyes are made out of? He's got a couple motors in his neck, which move the head to different positions. But then he's got this other position servo right here. And that's what's making his eyes blink. It's a very common craft supply. What do you think it is? I'll put my hand here for scale. What are his eyes made out of?
Paper, maybe? Emily chimed in first, although I think a bunch of people are seeing this. Toilet paper roll. You're absolutely right. That is just a toilet paper roll. So what's happening is this toilet paper roll is like rolling. It's being set to different positions, and when that position is down, we have this little black line drawn on the toilet paper roll. It makes it look like Matt the Robot's blinking, but all that's really happening is the toilet paper roll is moving.
Like that.
Pretty cool, huh?
Yeah. So you don't need a bunch of fancy stuff to do robotics. Just some motors. And they're not that fancy. They're all right. But you can just use, I'll show you some of our craft supplies that we use. And Matt, I can't see the chat, so if there's other questions coming in, if you could help me by reading them.
Oh, absolutely.
Here's some of our craft supplies. We have a lot of toilet paper tubes and boxes and pipe cleaners and paint.
Yep. Rue was wondering, are we doing all block-based coding? And Amanda was wondering if all of the robots are plugged in.
Ah, great question, Amanda.
Yeah.
Are we doing all block-based coding? Well, yeah, pretty much. Our website, I'll come back to our... Our website is coded, I think it's JavaScript? Is that what our website is done
Yes.
I don't know, because I didn't make our website. We have a third member of our team who doesn't live in the same town as us. He also works with us. His name is Mike Cotterman, and he is an amazing website developer. So we develop robots. He develops this website that you guys are using now to control our robots. So I think it's JavaScript that he uses. But everything that we do here in the studio is all block-based coding. Yep. So everything that we do, if you're about a third grader or above, you can do too. If you can understand percentages, you're ready to make a robot, right? And what was there was another question.
Are all the robots plugged in? That's from Amanda.
Yeah, totally. Here, I'll go back. Will you go back to our behind the scenes camera?
Yeah.
Yeah.
So,
okay. We'll go back to Elby here, for example.
Here's Elby.
Here's Elby. He's got some motors in his head, right? There's one, there's another one. They're kind of glued onto each other there. The wires come out here, and the wires are all plugged in to, again, a microcontroller. And the microcontroller, so here's the motors for Elby's head plugged into our microbit and hummingbird. And then yes, it does indeed have power. It's plugged in right here. So without power, we couldn't get those motors to move. Doesn't work with magic or happy thoughts. It requires amps and voltage. Yes. So all of our robots are plugged into some kind of power. Some of them, if we come back here behind the wall, we even have some power and circuits. So here's like the motor that's controlling the Mona Lisa. Here are the lights that are controlling those tiki guys. There's some other robots hiding out back here, but yes, all of our microcontrollers have power. They're actually plugged in to a circuit behind the wall here. So yes, robots need power. No power, no motion.
Bo was wondering if all of the robots are made out of cardboard. Yes, we love cardboard here. And Abby was wondering if we're going to teach you guys how to make a robot. No, today we're actually just recording, you're just controlling robots, so it's more about coding than the actual robotics. But Hannah was wondering if you could build a small robot right now. Do you think that's possible, Kelsey?
I don't know. What time is it, Matt?
It's 1:55.
1:55.
For them, what is that?
10:55, I think. Yeah, they've got a couple minutes here. I mean, yeah, kinda. I mean, I can kind of show you a really simple robot to make. Here's an example of a simple robot to make. I'll show you a couple examples. I'll kind of disassemble them rather than assembling them because that's faster. So this one, we call it the tiny drummer. And this one, it's just a popsicle stick drumming on a cup. So all you would need to make this robot is some cardboard, a motor, a popsicle stick, and a cup. So there's one really simple robot. Here's another really simple robot. This one is made just like Elby. This is actually Elby's grandpa, Grandpa Walter. But Elby's Grandpa Walter, I made it so I could pop the head off. Don't worry, it doesn't break it. It's all right. Here, I'll go to our top down here. So here's Grandpa Walter. And you can see inside that here's a position servo, which allows the head to move back and forth. There's another position servo glued to the side of the head there, which lets the head move up and down like that. So it's really just an X-Y axis. Sort of, it's got like two axes of movement. And then we cut a hole in the top of the body box, sink a motor in there. You can see it from inside here. Here's where the wires for the motor come out. We usually feed those back out a little hole down here so we can plug them in, but I'll tuck them in for now. And yeah, so making a robot is super simple. It can take anywhere from like 10 or 20 minutes to like hours and hours and days. This robot takes half an hour to build, if that. Build and program. If you've never done a robot before, this is a simple like 30 to 60 minute project. This one's maybe an hour or two. But Matt the robot, how long did it take to build Matt the robot?
It took several days to build Matt the robot and many iterations. So the first time we built it, it didn't look anything like this at all.
No.
And it didn't function anything like this at all. So Matt the robot has changed a lot over time.
And just for context, here's how big Elby is versus how big Matt the robot is. Yeah. Or Walter in this case. But also for the person who was worried, I put the head back on. Don't worry.
That was Elena. Yeah.
Elena, it's okay, Elena. Head's back on. Excellent. Okay. Well, I think we're just about at the end of our time, which is sad but true and does allow me to say my favorite thing, which is thank you. And we actually have a little message from Madeline to close us out today. So Madeline, want to take it away?
That's everything for today, folks. Thank you so much for joining us, and a big thank you to Kelsey, Matt, and Alfie for helping us learn some cool code today. If you missed anything from today's program or you would just like to watch it again, it will be on our YouTube channel sometime early next week, and so you can go back and enjoy it all over again. I also want to let you know that our next Girls in STEAM event will be happening on May 28th, and we are looking at marine conservation. So stay tuned on the Science World YouTube channel or the Science World events page for more information about that. Thank you again for joining us, and keep exploring.
Thank you so much, Madeline, and to all of Science World. We had a ton of fun here today, coding and showing our behind the scenes with you guys. You did an awesome job. And I wanted to tell you, if you want to check out more about us, feel free to join us on our website. You can check out our upcoming classes. There's a bunch of really cool ones, including a free public one in May. And if you want to follow us on social media, here's our Twitter and the Science World handle. You guys did an awesome job. Thank you so much, everyone. Bye. You can click log out on the top of CodeJoy Live.